I'm going to review with you how to factor 5 different binomial expressions. So in each one of these, we want to focus on a pattern. And if you're looking at my board right now, you're going to see that pattern. I believe it's in blue, maybe black. I don't have a good view of it right now. But these are the numbers we're going to be focused on. 1, 4, 9, 16, 25, 36, 49. I know you've all learned these before. 64, 81, 100. Doesn't just stop at 100. 121, 144, and it goes on and on and on. Now, how do we achieve those numbers? This is achieved with the expression x squared. So x is a natural number. So for instance, 1 times itself. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9, and so on. So if you see a 36 in this and you're like, oh, how do I achieve that? 1, 2, 3, 4, 5, 6. This would be 6 times 6. So how do I factor this? Because we need to completely factor it. I often use the example of if I tell somebody to solve something and I want it to be completely solved and simplified, and you give me an answer of x equals 10 over 2, that may be correct, but that would not be the answer I wanted. I would want an answer of x equals 5. I would want it completely simplified. Same thing. I want it completely factored. So when I look here, the first thing I have to check is there subtraction? If there's subtraction, I can move forward. If there's not subtraction, I cannot move forward. It is not factorable. The next is I'm looking up here to see a 9 and a 4. Sure, there's a 9 and a 4 here, and there's not a number that I can factor out that would simplify this. So I look here and I go, okay, 9 is the third number. So this breaks into 3 and 3. I take that a to the second, and when I divide it by 2, I get a to the first and a to the first. And 4 breaks into 2 and 2. So I have the 2 parentheses. Now, 3a came before the subtraction sign. It came in front of it, so it stays in front. 2 came from behind, so it stays in behind. 1 is positive, 1 is negative, and I'm done. It does not matter which one is positive. It does not matter which one is negative. If I see a cell phone, I will keep it. You absolutely can have it back when I see you next time, which is Monday. All right, next part. Completely factor. So I have a 16, I have a 1, and this time I have a c squared. Same thing as an x squared or an a squared. Now, a lot of students are going to break this into 4 and 4 and 1 and 1 and c. But notice the first thing I want to do is say, is there subtraction? If there's not the subtraction, then I'm not going to move forward. Not factorable. Don't just leave it blank, then I'm going to assume you don't know what the answer is. It is not factorable. Okay, moving on to number 3. So this looks just a little bit different. Now, when I look at this expression, I'm looking at an 8 and a 50, and I'm like, 8 and 50? There are none of the numbers up here, but that doesn't mean that I can't move forward. I have subtraction, and I have something that can be divided here, so f squared can be divided into f and f, so I know that's good, and I have subtraction. But what do I do here? So I always try to look at the smaller number. I want to do the simplest task in order to achieve my final answer. I look for the smallest number, which happens to be 8 here, and I go up above and I go, all right, forget about 1. That's not going to help us simplify anything. I go 1 by 1 here, and I go, okay, can I take this number times something and achieve 8? Can I take this number times something and achieve 8? And if it wasn't 4, then I go on to 9, and then I go on to 16. And I do know that 4 times 2. 4 times 2 is 8. So I'm going to try this. I'm going to factor out a 2. And I factor out a 2, so I know 2 times 4 is 8, bring down the f squared. I know 2 times 25 is 50, bring down the subtraction sign. If I stopped here, it would not be enough because I want to completely factor it. I have subtraction, great. I have a variable squared, so I can break that down into f and f. And now let's check, is 4 and 25 a part of that list? 4 and 25 are. It's the second number and the fifth number. 2, 2. F, 5, 5. Okay, so I'm going to bring my answers over here. The 2f came before the subtraction sign, so 2f stays in front. The 5 came behind, so the 5 stays in back. One of them is positive, one of them is negative. If this is your final answer, it would be wrong. It's not complete. Remember, we've factored out this 2. It has to be part of our final answer. Don't forget about the 2 out front. Okay, so we're going to move on here. A 128 and a 50. While I have subtraction, it doesn't matter if this h squared goes in the front or if it goes in back. Okay, that's okay. okay in front or in back. But I have subtraction, so that's a good thing. Now I look up here at 128 and 50. 128 and 50. Neither one are here. So can I go any further? So I personally choose to use the smaller of the two. So I'm choosing 50, and I'm going to go one by one. Again, one's not doing anything for us. Can I take 4 times some type of integer and get 25? No. Can I take 9 times an integer and get 25 and get 50? No. 16 times an integer and get 50? No. 25 times 2. 25 times 2. So I'm going to factor out a 2. Grab that calculator and please take 128 and divide it by 2. Take 128 and divide it by 2. Is that your sign C? Okay. 128 divided by 2 is 64. 50 divided by 2 is 25, and we have an h squared. Can I go any further? I'm not sure. I want to see if 64 and 25 are part of that list. 64 and 25. This is the 5th number. 6, 7. This is the 8th number. 8, 8, 5, 5, h, h. Now notice when I bring those h's down, they're no longer h squared. I'm taking this number and dividing it by 2. If you want to put a little 1 there, if that helps you, feel free to do that. So for my final answer here, h's came before the sign, so they're going to be out front. 5 h's came behind the subtraction sign, so they're going back. One of them is positive, one of them is negative. It doesn't matter which one's positive or which one's negative. And if this is my final answer, I'm wrong. And the reason is because don't forget about the 2 out front. Don't forget about the 2 out front. Okay, lastly, so I have subtraction, great. And I have a 16 and a 9. Let's check. A 16 and 9 here. Okay, great. 16 is here, and so is 9. 16 is here, and so is 9. Okay, that's a good thing. So when I think about breaking this apart, this is going to break into 4 and 4. This is going to break into 3 and 3. And now, it may be a little bit difficult to see because the camera is looking, it's not as clear as I'd like it to be. But this is an x to the 6th and a y to the 4th. So how do I break this apart? Well, let's go back and see what I did here. I take it and divide it by 2, which means 1 and 1. I take it and I divide it by 2, which is 1 and 1. So when I divide 6 by 2, I'm left with x to the 3rd and x to the 3rd. When I divide 4 by 2, I'm left with y to the 2nd and y to the 2nd. What do I do with those numerical values and variables? Well, the 4's and the x's came before the subtraction symbol. So 4x to the 3rd has to go in front. And the 3 and the y's came behind it. So 3y squared has to go behind it. One is positive and one is negative. We never factored anything out. This is my final answer.